In the year 1513, a Spanish explorer named Juan Ponce de Leon stepped onto the shores of what is now Florida, not chasing gold, but chasing a dream. A legend whispered across oceans and kingdoms, the existence of a fountain of youth, a sacred spring said to grant eternal youth to anyone who drank its waters. Ponce de Leon had sailed from the Caribbean, driven not by conquest, but by an obsession shared by kings, philosophers, and commoners alike. How can we live forever? Or at the very least, how do we slow the march of time? Though he never found the fountain, his quest became a symbol, etched into the pages of history, as one of humanity's earliest and most famous pursuits of anti-aging. Today, we no longer search in the jungles of Florida. We search in genomes, in molecules, in mitochondria and methylation clocks. So what do we now know about aging? What causes it? Can we prevent it? Or even reverse it? In this documentary, we explore the ancient questions and the modern science behind one of life's greatest mysteries. Why do we age? Today, we define aging through a more scientific lens. The World Health Organization describes aging as a process of progressive change in an organism over time. It's a complex interplay of biological, psychological, and social factors, leading to a decline in physical and mental capacity. This decline, however, is not uniform. It varies greatly among individuals, influenced by genetics, lifestyle, and environment. Demographically, the world is aging at an unprecedented rate. By 2050, the global population aged 60 and over is projected to reach 2 billion, more than double the number in 2015. This demographic shift presents both challenges and opportunities. On the one hand, we face increasing demands on healthcare systems and social support networks. On the other hand, it presents a chance to redefine traditional notions of aging, recognizing the contributions and potential of older adults. Modern science has made significant strides in unraveling the biological mechanisms of aging. At the cellular level, several processes contribute to our gradual decline. Telomeres, the protective caps at the ends of our chromosomes, shorten with each cell division, eventually leading to cellular senescence, a state of irreversible growth arrest. Oxidative stress, an imbalance between the production of free radicals and the body's ability to detoxify them, damages cells and contributes to age-related diseases. Mitochondria, the powerhouses of our cells, also play a crucial role in aging. As we age, mitochondrial function declines, leading to reduced energy production and increased oxidative stress. This decline in mitochondrial function has been linked to various age-related diseases, including heart disease, Alzheimer's disease, and Parkinson's disease. Understanding these cellular and molecular processes is key to developing interventions that can slow down aging and promote healthy longevity. Despite scientific advancements, myths and misconceptions about aging persist. One common myth is that cracking joints are a sign of aging. While it's true that our joints undergo wear and tear over time, cracking knuckles doesn't necessarily signal impending arthritis. Another myth is that mental decline is an inevitable part of aging. While some cognitive changes are normal with age, maintaining mental sharpness is possible through mental stimulation, social engagement, and a healthy lifestyle. Recent scientific breakthroughs offer exciting possibilities for extending lifespan and health span. Senolytics, a class of drugs that selectively eliminate senescent cells, have shown promise in animal studies in delaying age-related diseases. CRISPR technology, a revolutionary gene editing tool, holds the potential to correct genetic defects associated with aging. While these advancements are still in their early stages, they offer a glimpse into a future where aging may become more manageable.